Okay, Thevenin theorem, example 2.7. Now let me see how this question to be solved. For example, you can refer to example 2.7 in my PowerPoint slide. There will be also a step-by-step solution there. Okay, now I want to show you how you can answer this question in your exam. Okay, we will follow the structures of examination. So first step, okay, so you have to know where is the current IL that is required by the question. Here IL will be in the center of the circuit that flows through resistor 220 ohm. So first of all, we have to calculate the VTH first. Okay, calculate or determine VTH. Okay, so we draw again the circuit, and remove resistor 220 from the circuit. Okay, now we show you like this. So here is 12 volt, 100 ohm, and 9 volt. Okay, so our VTH now is here across these 2 points. Okay, so this will be, so I put red color here, so this is positive, negative of VTH. Okay, so now it will be quite difficult for us to see what is VTH actually. Okay, so now the idea is, after we remove 220 resistor, actually the circuit will be changed from series parallel to series circuit here. So we have two supply 12 volt and 9 volt, two resistor 100 ohm and 100 ohm here. So first step is you have to determine first what is the new current that will be flowed through this circuit from the supply. So we have 12 volt supply that against the 9 volt here, but 12 volt will be greater than 9 volt, so the direction of current will follow the direction from 10 volt. So current will be flow from here. So this is your I. Let me put here IT, let's say. Okay, now we have to calculate this IT. So IT equals to 12 minus 9 divide V over R. So R is the total of this series resistance, 100 plus 100. Okay, so you have 12 minus 9, 3 divided by 200. Okay, so we get 15 milliampere. 15 milliampere. This is the IT here. Okay, the current that flows through this. Okay, now after we know the current flow, value of current, so we can we may label all the voltage here. So we have 12 volt here, so this negative, positive, and the voltage drop across 100 ohm here is positive. We receive current, negative here. So IT will flow in here, so this will be positive, it will be negative, and now this will be positive and this will be negative. Okay, now VTH is actually the total amount of the voltage here, supplied voltage here, with the voltage drop here, and also equals to voltage drop here, total amount with the 9 volt here. Okay, but we have to be very careful. Okay, because we have to see the direction of plus minus of the voltage. Okay, if it's in same direction, that will be the positive sign. So if negative, then it will be the negative sign. So let me label here. Let's say this is V1, this is V2. Okay, actually, for if we compare VTH to the left wing, okay, left wing here, so actually VTH is equals to 12 volt is just in same direction of VTH, so we can write down it as positive 12. Okay, but V1, it is against 12 volt, so it will be on the opposite direction of VTH, so we have here minus V1. Okay, so for that, so 12 minus V1 is 100 times I1, so 100 times 15 milli. So you will get the VTH now is 100 times 15 milli. Okay, 12 minus answer, so 10.5. So 10.5 is the VTH. 10.5. Okay, or if you refer to the right wing or right side of the circuit, okay, if you referring to the right side, we have 100 ohm and 9 volt here, so VTH equals to, okay, here we have voltage drop V2 is actually in same direction with VTH, so positive is face to positive, so negative there, so it's equals to V2, and 9 volt is in same direction with VTH, so it's plus 9. So what we get here is 100 times 15 milli plus 9, so we may get the same answer, 10.5 volt. Okay, so you can choose either to use the left side or right side of the circuit to determine VTH. Okay, now we already have the VTH, so let me go to the next step, calculate RTH. So we calculate RTH. Okay, for RTH, we remove supply from the circuit, then we draw back. Okay, so leave you open point here. So our RTH is in the middle, so refer upon the 2 point. Okay, what we can see here is there are two resistor 100 ohm which is connected in parallel. So RTH equals to, because the resistance in same value, so 100 divided by 2 will be simpler solution, 50 ohm. Okay, so that is our RTH. Okay, now we go to the next step, is the last step, draw Thevenin equivalent circuit. Okay, so Thevenin equivalent circuit, voltage, resistance. Okay, so we have VTH 10.5 volt, RTH 50 ohm, and then we place the 222 ohm resistor here, which is your RL, and now this is your IL. So your IL equals to 10.5 divided with 50 plus 220. So 50 plus 220, 10.5 divided by answer. So you get here 38.889 milliampere. 38.889 milliampere. That is your IL for this question. So we have here our VTH 10.5, our RTH 50 ohm, and our answer is IL equals to 38.889 milliampere. Okay, I hope you can follow this solution. Okay, thank you. That's all.